I'd like to welcome back our judges, resuming their positions from yesterday. Hannah Bailey, she is the Emerging Technologies Integration Engineer at Ford. Giancarlo Savini, Investment Director at Honeywell Ventures. And Leonie Lirikun, she's an investor at Kinetic VC. So welcome back, judges, for session 2.
Thank you.
So here's the pitch order for today. And with that, I'd like to invite our first presenter to the stage, Megorian, who is re-engineering plastic waste into new materials for road construction.
The majority of plastic waste now are either incinerated, landfilled, or leaked into our environment as pollution. We solved the big plastic waste problem, converting all this waste into a new construction material, new bitumen. We prototyped 3 generations over 7 years, through different processes, configuring molecular compounds and catalyzing chemical links. Rather than fully rely on fossil-derived bitumen to build all roads, now we can use plastic waste as feedstock. Our product is more sustainable, safer, and cheaper compared to traditional bitumen, which is also currently facing a shortage as all refineries worldwide closes. Our new bitumen plugs this shortage while solving the world's plastic crisis. Compared to our competitors, our technology is different. Our competitors are competing with current demand for the same 4% of clean and sorted plastic as feedstock. This means we still have a big plastic waste problem. Our technology, on the other hand, solves the plastic problem by recycling contaminated and mixed plastic waste. This is because our processes are chemical rather than being purely mechanical. Other advantages include being more environmentally friendly and at least 3 times cheaper. We already know the detrimental effects of plastic waste, from pollution to incineration and landfilling. The environmental harms are made worse by crude oil extraction to import and refining bitumen for road construction. We reduce all of this by creating a green loop, converting plastic waste into new bitumen for road construction. To summarize our impact, we create a truly circular economy, solve the plastic waste problem, create a green construction material, reduce carbon footprint, import reliance, and importantly, reduce consumption of finite resources. Through plastic waste recycling, new bitumen production, and building eco-roads, our revenue streams include waste processing fee and new bitumen sales. Singapore spends $68 million incinerating plastic. We aim to process at least 35%. The global bitumen market is huge. We aim to replace at least 0.7% with new bitumen worth $800 million. Our third and newest revenue stream is carbon credit, which can be generated and sold by us keeping up all of these different emissions. Large corporations see investment potential in carbon offsets, while 57 countries committed to net zero emission targets at end 2020. This actually shifts carbon compliance from a voluntary one to mandatory. All this really just means that there is unbelievable potential for growth of carbon credits. We are creating more than a revenue model, but an entire ecosystem, incentivizing different stakeholders to recycle plastic waste while creating a more sustainable construction sector. So our story began in 2014, co-authoring a research journal and presenting it in an international conference in 2017. After building 2 pilot-based roads, we won different awards, competitions, and funding. We have been featured in this media. This year, after developing Gen 3 prototype, we engaged various state boards, government agencies, and authorities for relevant testing and pilot projects. Our team consists myself with 7 years experience in sustainability and construction space, Seong Hot co-authoring 3 different plastic waste research journals, and part of the team clinching a $1 million Closing the Waste Loop fund. Alfredo with 17 years experience in road materials and specs. Finally, King Kyung with 30 years experience as a machinist with expertise in fabrication and customization of prototype systems. Our core partners include Dr. Raymond from NUS School of Civil and Environmental Engineering and Dr. Xia Cheng, a sustainable researcher from A-Star. Our technology can literally pave the way to a sustainable future. Thank you.
Great, thank you for your presentation. Over to you, judges, for your questions.
So I do have a question for you. Thank you for that. What I'm wondering is if you've looked, or if you could speak to the production process of new bitumen and what sort of emissions or what it takes, the supply to create that and the sustainability of the overall new bitumen product.
Sorry, but I think your question got cut halfway through. Could you just repeat the question? I couldn't quite catch the full question.
Yes, of course. I was hoping you could speak to the production of new bitumen, and if you've done any sustainability analysis for the long-term production of the material that you will be needing. What does it take? Did that come through? Victoria, did that come through?
I heard you.
I think we caught
Chushan, your screen froze. So did you hear Hannah's question? You did, right? Okay, yeah. So go ahead and start your answer.
I think I caught. I think I caught the gist of it. So basically, I think what you're asking is the emission and the environmental effects of production of new bitumen. So basically right now we're doing a life cycle assessment, and this is how we intend to do our carbon credit generation as well. We are doing it with A-Star, a research institution in Singapore, and from the preliminary ones, we are actually carbon deficit purely because we do, so it's 40% yield of new bitumen from 100% of plastic. So the rest can actually be powered back to heating up to powering the entire system itself. So it's a closed loop system.
Thank you.
I have a question. Yeah, go ahead, Leonie.
Shushan, I may have missed it, but what's the amount that you're raising and what would the use of funds be for?
I'm actually raising $3.5 million SGD, and this is actually for commercialization. So right now I have 3 different equipment and hardware prototypes, which are disjointed. And what I intend to do with this fund is actually to integrate the entire thing, because right now it's very manpower intensive, taking it from one system to the second to the third. So what I want to do is integrate and automate this entire thing, and this will be a mini scale of what the future facility will look like in Singapore, which will have dual function of recycling plastic while producing new bitumen all in one.
And the facility will continue to be based in Singapore?
Right now, we are prototyping a facility in Singapore also because waste is very regulated in Singapore, and that is one of our revenue stream, which is very guaranteed. Because right now, to dispose of plastic waste is $77 per ton, and this can be used. This can be diverted into our revenue stream. So we want to create a model in Singapore before we bring it to other countries, but we definitely do intend to scale internationally.
Okay, thank you.
Chushan, one of the biggest problems in plastic recycling is waste aggregation from municipalities, getting access to that feedstock. Do you already have some agreements with one of those MRFs or municipalities? Apologize if you already mentioned it, I may have missed it.
No worries, I understand. So yes, I think you're right. Definitely getting a stable supply of plastic, it's a concern once you want to invest in a facility. So right now we are speaking to a waste management company in Singapore, one of the big ones, as well as we are speaking directly to the waste generating company. So these companies are actually approaching us because they're sick of paying $77 per ton of plastic waste generated to incinerate. So rather than incinerate all of this, in Singapore, we actually incinerated 900,000 tons last year. So this 900,000 tons has that potential to become our stable supply, and we are speaking to a few of them. One of them actually generates 200 tons per year, and they've been incinerating it for the past 5 years. So these are the people that we are actually signing MOUs with to guarantee a stable supply of plastic waste.
Okay, thanks.
Thank you for your presentation, Magorian. Thank you.
Thank you.
Okay, 30 seconds for the judges, and then let's invite up Apollo to the stage.
So nice to meet you. My name is Elad. I'm VP Business Development at Apollo, and I'm the 4th person in the company. And basically, I'll start with a demonstration, and then we'll go for the presentation. So 99% of the solar panels today are built out of silicon, rigid silicons that are very good. You can see them everywhere, but they have one problem. They are brittle, and you can't really bend them. What happens is, in order to protect this silicon, you put a heavy, big chunk of glass above them, and that really puts a lot of limitations on the solar and where you can deploy it. In Apollo, we developed a very flexible thin layer that is cost-effective, efficient, and durable. And most important, it can go into every material. So this is the technology. And basically, after that, everything else is building the application for the customer. So it can be a phone charger in Africa, and it can be something colored for architecture, and it can be implemented in composite materials or plastics for the automotive or for trash cans. And as you will see in a minute, it can even be a 50-meter long roll that you can deploy basically everywhere. So now for the presentation. As I told you, our goal, we have the technology, but our real main goal is to rethink energy. And when I say rethink energy, why do we need to rethink energy? As I said, today solar has a lot of limitations. If we look at the floating site, today floating site ratio is 80% floaters of plastic and a lot of containers that basically raise the price and you transfer air, basically. And of course, after 25 years, you have a lot of plastic that you don't know what you can do with. Our goal is to reduce most of these plastics because our film, as you can see here, can deploy and float by itself and be on the water itself. On buildings, this is actually a market that we didn't approach at first, but the customers came to us. Today, a lot of buildings can't carry the weight of regular panels because they are old, because they have different angles, or because they have a unique shape that they want to maintain. So our technology allows them to install solar energy, basically on every building. And today we have a contract with Tadiran, a company in Israel, for 26 megawatts for 3 years, and several big companies in Europe that are now looking for installations on their factories that are too old and can't carry the weight of regular panels. And lastly, another main market is the automotive, basically embedding our solution. Today we're working with 4 OEMs and 3 fleet owners. With the OEMs, we're working on an embedded solution, and each OEM takes it to a different use to maintain the batteries, to ventilize the vehicle, or other usage that they are looking at. And as you can see here, this is an embedded solar hood. You can't really see it. It's automotive grade, and it's part of their production line. And for fleet managers, we are basically solving energy problems. 2 examples I can give you. One, for buses in Israel, they have a lot of machinery or computers that keeps on working, and then they can't start the engine when they come on the morning. So our system basically generates energy for those systems. And we have a customer, a big beverage company in the US that has a problem with their lift gate when they're doing their shipping the material, and we're charging the lift gate and solving that problem. Our leading customer today in automotive are Audi, Renault, CVT, and more. Why do we want to rethink energy? So we want any surface under the sun to create energy. We want to produce energy where it's being used, where the customer needs it, and we want to reduce our footprint. Lastly, our team is of 50 people. We have a production line of 10 megawatts, and we have a proprietary technology with 8 patents. Thank you very much. This is the future we see. Every road basically can light the whole US. Thank you very much.
Thank you, Elad. With many significant competitors in this space, this is Leonie, sorry. With many competitors in this space, how do you plan to maintain market share or gain?
So, there are other flexible technologies, but each lack or has a problem that we don't see them. Those are technologies we have for 10 years or more, and you don't see them everywhere. And the reason is because they have either an efficiency problem, a durability problem, a cost problem. And basically what we're doing, our efficiency is very close to regular panels. We are 17% and aiming for 20. Our durability, we are certifying for IEC, for the solar regular certification that the regular panels are doing. And for cost, today, the project we are doing today in large scale, the total cost of the project is the same as regular panels. You don't pay premium because we are flexible.
Thank you.
What's your current investment situation? Are you raising soon? What sort of size are you looking for?
So we are not raising. We are a public company in Israel, and we just raised $35 million from the financial institutes in Israel for a bigger facility. Again, 10 megawatt is a small facility in solar scale. So we are now building a large-scale facility in Israel because we have a higher demand than we can supply. And that's, for now, we are in a good position financial-wise.
Okay.
And you answered my questions through the other questions, so thank you, Elad.
Thank you.
Great. Thank you for your presentation.
Thank you very much.
Okay. Next up, I'd like to welcome Thomas from EcoTree. EcoTree contributes to reforestation and supports biodiversity in France.
Right. Can everyone hear me well?
Yes, and we can see your deck.
Okay, and you can see my deck. That's fantastic. Okay, great. Well, so hi everyone. I'm Thomas, and I'm one of the co-founders of EcoTree. EcoTree is a startup that has become one of the missing links between climate change awareness and tangible action by making tree planting not just a feel-good donation, but an actual financially rewarding investment. It all started back in 2016 when it became clear for us that we needed more trees and more healthy forests, simply because they are among our best allies to fight climate change. But the big question was, how are we going to make that happen at a scale that would actually have a significant game-changing impact on this environmental crisis? And that's when we came up with a simple but powerful idea, which was to use the proven method of financial incentive to get everyone engaged in planting more trees and growing more sustainable forests. We actually got inspired by the Scandinavian return system for used bottles and cans, which successfully monetizes the act of recycling, and we decided to apply it to tree planting. So instead of taxing, scaring, shaming people or those who are not environmentally friendly, we realized we would have a much bigger impact by actually rewarding financially the virtuous ones. So we've built a simple model from there. First, in a few clicks and for as low as €15, anyone, firms or individuals, can buy online newly planted trees from our forests in Europe and become what we call a tree owner. Then we at EcoTree take care of the planting and also make sure that your trees will grow into durable and healthy ecosystems. And we have developed some great digital features so you can follow it all online on your personal or company account. And once your trees have reached maturity, we're talking 40, 50, 60 years time, and we selectively cut them, you as the owner will get 100% of the revenue generated by the sale of the timber. So you will ultimately more than double your initial investment, which is a decent financial reward for doing the planet a favor, right? So practically, we offer individuals, on the one hand, like you and me, the opportunity to buy trees as the perfect gift for their loved ones, as a good way to diversify and greenify their investment. And we even have a subscription model where you automatically get new trees every month. And for companies, buying trees with EcoTree is the perfect opportunity to invest in carbon sinks that basically will pay for themselves, unlike the classic carbon credits. But it's also a good opportunity to make gifts to the employees or engage the customers with a sustainable and meaningful product. After 4 years of operations, we're now a team of 60 with a unique combination of legal, financial, forestry, of course, as well as digital expertise. And that's how we got recognized and endorsed by those solid international watchdogs. And we convinced more than 55,000 individuals and close to 2,000 companies to plant more than 1 million tree now with us. In 2019, we stepped out of our domestic market to duplicate our model internationally. And we've developed a so-called forest lease model where we simply deal with existing land owners and run our model on their land instead of acquiring the land ourselves. So we now can scale our model in basically any temperate region of the world. So in a nutshell, good news, there is now a simple, tangible and profitable way for everyone to do our planet a favor, and it starts on ecotree.green. Thank you so much. Happy to answer your questions.
Hey, Thomas, thank you for that. I have a quick question. Can you speak to how the profitability comes out from your model?
Sure. You can see it here. Basically, when we sell a tree for 15 euros, roughly 30% covers the cost of planting, land acquisition, and so forth. Another 30% is actually our gross margin, because that's where we earn money. Again, the proceeds of the timber goes 100% to our tree owners, to our customers. And then the remaining 40%, as you can see here, actually cover the the long-term forestry management, because it is vital to be able to deliver the environmental benefits we're offering, that you secure the long-term financing of the product of the whole forestry ecosystem. But so our margin is roughly 30% and occurs at the sale of the trees.
Thank you.
Hi, Thomas. This is Leonie. How exactly are you contributing to the environment when you're cutting the trees down ultimately? And after, what is the life cycle of a tree?
Yeah, the life cycle of a tree depends on its species, of course, and the location will, of course, also impact how quick it will grow and reach maturity. What is vital for me to say is that we never do a clear cut, when you remove everything. We do what's called thinnings. So we do selective cuts when some trees have been identified as mature. And then we either let natural regeneration occur, and take like the next steps, or we replant, so that we continuously have a healthy, optimized, and even boosted, you could say, forestry ecosystem.
Thomas, are you planning to expand geographically, or your business model is for now mainly tailored to France and Central Europe?
No, so yeah, our model is based for now on what we call temperate forests, which is basically not the tropical ones and not the boreal ones. But as you could see here, it's kind of still covering a decent area of our globe. So our model is tuned for now to expand naturally on these markets. So it goes from Asia, the whole European region, North America, as well as some region in Oceania or South America. So there's still great room for us to grow and to scale and have an impact on our planet. Okay.
Thomas, can you walk us through your team?
Sure. Well, first thing maybe it's interesting is we're 5 co-founders, all very complementary with different backgrounds. And as I said, then the rest of us, around 55 teammates, we are 12 in our international operations, which I am running actually from our international head office in Copenhagen. The rest of our team is mainly in Paris. And yeah, it's a great, as I mentioned, it's a great combination, I think, of both legal background, because there's a legal background behind this whole ownership model. Of course, a financial aspect as well, because we're dealing in every new country we address, we deal with the financial regulator in order to comply with whatever regulations they may have. So there's some sort of financial mechanism part of our team deals with. Of course, a lot of the digital experience. We have continuously new features, from satellite monitoring to time-lapse videos, even IoT devices on some trees to measure their growth. so we can share all that and make it as concrete as possible for our tree owners. So a lot of tech and digital expertise. And last but not least, and that's also important to mention, is that we are fully integrated forestry company. And I like to say that we are a startup that didn't start in a garage, but actually in a forest, because we do have our own forestry team from the field, forestry experts, all the way up to the scientists that actually, modelize our carbon computation methodology and so forth.
Thank you.
Hey, any more questions from the judges?
No.
Great. Thank you, Thomas from EcoTree. Thank you.
My pleasure. Thank you so much.
Okay. Let's have BioElements group to the stage and set up screen sharing.
Okay, guys, can you see my screen?
We can see your screen. Nothing is playing yet. Okay. Okay, there you go. We see the image. And we can hear you.
Okay, thank you. Well, my name is Ignacio
hold on.
Bada.
Ignacio, just give us 10 more seconds, please.
Ya me voy.
Okay, please start.
Okay. Well, hi, my name is Ignacio Bada. I am the founder and CEO of BioElements, and we are disrupting the packaging, plastic, and paper company industry by producing fully biodegradable, compostable, and non-biotoxic biopackaging in Chile, Peru, and Mexico. This is really our purpose, to revolutionize the conventional plastic industry and packaging industry status quo. Why? Because we reduce plastic biodegradation from 400 years to only 6 months. Plastic, as you know, is a very versatile material. It is present worldwide and in almost every industry. But its recycling process is very complex, so less than 10% of it is actually recycling. And this has made today one of our biggest environmental issues worldwide. So we asked ourselves, what if plastic wasn't really plastic? And that's how we developed our BioE8 bioresin, which is a bio-based, renewable, biodegradable, and non-biotoxic bioresin that replaces traditional plastic and has been certified by multiple labs all around the world. Today, all of our finished products are certified as biodegradable under compost situations in only 6 months, landfills and oceans conditions in 16 to 20 months. There is no competitor nor any alternative to plastic, like paper or cardboard, that has proven to be biodegradable in all these type of environments, and also non-toxic or toxic by heavy metals. We believe in the triple impact of our solution, and that's why we've been certified as a B Corporation and just got selected as Endeavor Entrepreneurs. In 2019, we sold $11 million, in 2020, $30 million, and in 2021, by consolidating our position in the countries that we are and opening in the USA, Colombia.
Hey,
Brazil.
hang on. I'm sorry to interrupt you, Ignacio. We don't see your screen share anymore.
Oh. It's the less important, but
okay, that's okay. Pardon me for interrupting.
No worries. But in 2021, as I was just saying, we're planning to sell $50 million, and by 2022, we plan to reach the $100 million sales goal. We are growing, and we know that it sounds ambitious, but we are sure that we can solve the global plastic problem and paper problem much more rapidly by winning this year's XTC. Thank you. I was a couple of seconds slower than the video. I'm sorry.
Oh no, not at all. No, it was fine. Great presentation. Over to the judges. Thank you.
Ignacio, some of the MRFs or let's say municipalities are also struggling sometimes in managing biodegradable materials. So indeed it is biodegradable. Sometimes it still takes time and effort and technology to actually make sure that this material is biodegrading. What's your view on that?
Yeah.
Could it be as a source of issues, or could it slow your growth?
Yeah, that's part of who we are is that, and our revolution, what we are actually doing is that our material is not only biodegradable under laboratories conditions or composting conditions, such as the ones that you can find in a municipality, but also in a landfill. We're biodegradable in 16 to 20 months, fully biodegradable in landfill conditions, where more than 90% of all the organic and inorganic waste ends, sadly. And we're also biodegradable by the action of ubiquitous fungus like penicillium fungus that is basically everywhere. It doesn't matter of the conditions. It could be anaerobic, aerobic conditions, mesophilic or thermophilic conditions, and you will always find these fungus, and we will always be biodegradable by the action of it. So in the end, we will fully biodegradable in basically every condition, not only compost facilities. And that's our big difference from other biodegradable products in the market. And that's how we are also solving the problem also for the municipalities and waste management problems that you just said.
Okay, thanks.
Hannah, you're on mute.
Sorry, go ahead, Hannah.
Oh, sorry. Go ahead, Leonie.
No, Leonie, you can go.
Okay, I'll make it quick. Ignacio, what would you say is the biggest advantage of utilizing resin and as opposed to like an algae? Since there are a lot of other plastic alternatives that have also come up utilizing different compounds. So why resin?
Our bioresin, well, this is a very big problem. It's not going to be solved, the global plastic waste pollution problem, with only one alternative. We are one alternative and we believe that our main difference is what I was saying before, that we are biodegradable not only in laboratory conditions, but also in many places, basically every environmental condition that you can find. Another good thing about our products is they're not biotoxic, so they will not harm the environment when biodegrading, and they're also non-toxic by heavy metals, comparing to many paper and cardboard products that could and basically are biotoxic and toxic by heavy metals. So that is something very, very important. I don't know if I answered your question.
Yeah. Yeah, I mean, some of the others are also biodegradable within a shorter amount of time. You also just mentioned that you've tested for different environmental climates and conditions. How many have you tested?
We are biodegradable in aerobic conditions, with high and low temperatures, such as home composting or industrial composting. We are also biodegradable in landfill conditions, which are usually aqueous conditions with water and no oxygen, and the temperatures are very low, not more than 40 degrees Celsius. And 90% of all the waste in the world goes to a landfill, so we are biodegradable in that condition. Is very awesome for a product to biodegrade in those conditions. And we are also biodegradable, as I said before, by the action of ubiquitous fungus, such as penicillium fungus, for example, the one that you find in your kitchen when a lemon starts decomposing and you start to see some hair, gray hair or white hair in that lemon. That hair is a fungus that is actually eating that lemon. The same happens to our product. Doesn't matter what the conditions are. Obviously, it will biodegrade much more rapidly in aerobic conditions because the condition is more biodegradable friendly than in anaerobic conditions. But we are biodegradable in 99% of the places because the fungus is everywhere. And that is something that's why we are very different, and that's the reason why we're here, basically, because we've proven that a material could and is biodegradable, not only in laboratory conditions, but also in normal conditions and by the action of this fungus.
My question follow up on that. What is part of the production? What does it take to produce your biomaterial?
We're producing, that's a very good question. We started by having big complications with the production. And today, the last generation that has been in the market for the last 4 years, we use conventional plastic machinery. So we're using all the production sites that were producing plastic, for example, in Chile and Mexico. 2 years ago, and now they're producing our products, and basically we have solved that problem in a very good way, because we can put our bioresin in basically every normal conventional plastic machinery.
And are the materials that form the resin traditional as well, or are they?
No. What is made of? Okay. If you analyze the composition of it, you will find around 70% of it's biomass. Could be PLA, acid polylactic acid, or starch. It's a starch combination, and also other fossil products that are also biodegradable, such as PBAT and others. And that's basically our formula. 70% is biomass.
Thank you.
Around.
Victoria, do we have time for one more question?
Yeah, go ahead.
Ignacio, what's your background and who's on your team?
I'm a lawyer. I started with my partner, who's an engineer, and we had this idea 7 years ago. And there was we thought there could be an alternative for products like ours, and that's how we developed the first generation of the bioresin together. Obviously, he knows more chemistry than I do, but I think the being a lawyer helps you to put things in the real world, and that has been the way that we've been working. We are today 45% contracted in the company in the 4 countries that I just mentioned. We're opening this year in the USA and also in Brazil. We subcontract, as I was responding to the previous question made by Hannah, we subcontract around 250 people monthly in the factories that we work with, where we produce our finished products. That's the team.
Great, thank you. Oh, sorry, Giancarlo, go ahead.
Nope, I said okay.
Okay,
thank you.
Great. Thank you, judges. Thank you, Ignacio from
Thank you.
From Bioelements. Now, next up, let's welcome Pellet Mexico Bioenergia. Oscar, let's take 30 seconds to get you set up.
Yes. So there you can hear me and see my screen?
Yes. Mm-hmm. It's coming
Okay,
through.
let me know when I start, Victoria.
Okay, 10 more seconds. Okay, Oscar, please begin.
Okay, so climate change is the greatest challenge humanity has faced throughout its whole history. If we do not change radically the way we use our resources, our life, our planets and species is threatened with extinction. Access to renewable, competitive, efficient and green fuels has become a vital necessity. Hi everyone, my name is Oscar Espinosa, founder and CEO of Pellet Mexico. Our company is developing the bioenergy and biomass sector by harnessing the energetic potential of agricultural, organic and woody residues. Our objective is the production of a solid biofuel, better known as pellet, that substitutes fossil fuel consumption for heat generation in the industrial, hospitality, and domestic sectors. Our solution has some incredible advantages. We add value to agriculture by generating an additional income for producers. We reduce water, air, and soil pollution, diversify the renewable energy market, cost by 30% in fuel consumption, and mitigate CO2 emissions. We are first to market on an industrial scale, and our innovation lies in the creation of a whole new value chain to develop an internal consumption market. We designed a regional business model in which we partner with farmers, producers, and companies owner of these residues, and with them we invest and manage a pellet production plant that commercializes its final product in a 150-kilometer radius. That way we guarantee supply of feedstock, avoid price speculation, and deliver our final client with a long-term supply contract at a fixed price. Pellet Mexico's strategy is divided in 2 phases. First, we develop our current assets and prove their profitability, and then we scale, arriving at 130,000 tons annually, replicate to LATAM, and access the world's export market. But not only that, we are currently disrupting our own business model to enhance more impact. An innovative formula where less is more. A small-scale, organic, decentralized growth to increase replicability. With Pellet Jalisco, we're going to be able to replicate with less investment, less feedstock for product, and of course also lower risks, but more social and environmental impact. Where pellets substitute high fuel costs in low-income areas, we eradicate hard labor for women and children who pick up wood for cooking and heating, and we eliminate respiratory health problems, empowering communities to learn, manage, own the productive process, and providing them with sustainable innovation, economic opportunity, and improving their overall well-being. Our market represents only 0.6% of a total available market valued at $4.8 billion US. Regarding traction, we have invested $3.2 million in our current assets. We have raised capital for $2.5 million, had a turnover to date of $500,000, and pellet sales for $20,000. We have 2 industrial and 1 domestic pellet adaptations working to date. We have built a wide global alliance, and our entrepreneurial journey has been recognized internationally. We have a multidisciplinary team with Mexican and European experience and a consolidated board of professionals internationally recognized by their experience in areas that are vital to our company. We are part of the 10,000 efficient solutions globally distinguished by the Solar Impulse Foundation for our profitability and scalability model. In just 6 years, we could be able to mitigate 2.7 million tons of CO2 annually. We are raising $1.4 million US for machinery, equipment, working, and operating expenses. There is a Native American proverb that says, we do not inherit the earth from our ancestors, but we borrow it from our children. The moment has come to raise our climate ambition and action. Thank you very much.
Thank you, Oscar. Judges?
Yes, I have a question. I was wondering,
Yes.
what are the emissions associated with your product?
Well, the pellet combustion has been recognized as a neutral emission because it follows the natural carbon cycle. I mean, one of the most ambitious environmental laws is the one in Europe right now, and the 63% of Europe's renewable energy comes from biomass combustion, which is regarded as emission neutral.
Thank you.
Yeah, you're welcome, Hannah.
Did you notice any competition for the feedstock? Are you? I think this is another field where feedstock competition is key. What's your view on that? Did you encounter some blockers, or you still have enough feedstock?
Yes. Well, in Mexico, what you see with the feedstock is that normally you would find this feedstock, that it's burned to the air or buried in the soil, and there's not a lot of energetic utilization of this feedstock, nor different innovative alternatives to use the feedstock. Mexico has a potential for biomass combustion and biomass potential of 1,600 petajoules, and none of it is being used right now. And that's why we developed our business model, and that's one of our innovations. It's the partnering formula. So we partner with the ones that own these residues, so we can guarantee our feedstock supply. And that way, we not only guarantee the feedstock supply, but we also avoid the price speculation in the feedstock in a long-term journey. And we can also contract with our final customers long-term supply contracts at fixed price, which is a very interesting competitive advantage for them.
Okay, thanks.
Oscar, and how many clients or contractors do you have now? Not contractors, clients essentially?
Yes, of course. So our former history as a company, we were founded in 2017. We designed this regional model and we raised capital for our investment in our current assets. So our first plant started operation last month, and we already have 4 clients which we are delivering to, 2 domestic adaptations and 2 industrial adaptations. But actually, our commercial phase starts till next August. Our really commercial operation of our first plant for operation. In Chihuahua, we will be operating in January of 2022, and in Pellet, Jalisco, we'll be operating also in the first months of next year.
Okay, great. Thank you.
Thank you, Leonie. Thanks, everyone.
Any other questions? Great. Thank you, Oscar from Pellet Mexico. Okay, next up, let's invite up Gelitex to set up.
Can you hear me?
Yes, we can hear you and can see your deck.
Perfect. Nice to be here.
Great. Nice to have you. Okay.
Thanks.
Okay, you have the floor.
Okay. Hi, I'm Märt Eerik. I'm co-founder and CEO of Gelitex, a materials technology company focusing on nanofibers. Now I'm going to let you into the world of nanofibers and how our materials are going to change the world. So nanofibers are really tiny fibers that are over 100 times smaller than a human hair. Because of unique properties such as small pore size, low density, high surface to volume ratio, they are used in high performance applications such as filtration, wound care, cultured meat, energy storage, and so on. The demand is growing, especially for eco-friendly and bio-based ones, but currently there is no way how to produce these materials on a large scale, especially with bio-based and biodegradable materials. Because of this, one A-size material with a weight of only 1 gram can cost thousands of euros. So commercialization of some of these products that could make our life easier, more sustainable, is just not worth it. So our solution is a patent-pending method that is the fastest technology to produce bio-based nanofibers on a large scale. Currently, the most common method to produce nanofibers is electrospinning, but the biggest industrial unit that is commercially available costs 8 million to build and outputs only 360 grams of material per hour, whereas our semi-industrial prototype that is up and running can already produce 4 times more material and costs around 200,000 euros. So combining these two aspects, lower initial investment plus much higher throughput per one production line enables us to reduce the cost of nanofibers more than 90%. In addition, our technology uses less electricity per kilogram of material. Besides offering better price, we can produce material which morphology and structure is more similar to the extracellular matrix. So extracellular matrix is a stuff between the cells in a human body or mammalian body. This is really beneficial. This advantage is really beneficial in the fields of tissue engineering, wound care, and most importantly, cultured meat, which is our novel food. So besides price and unique morphology, our technology is versatile. We can work with different raw materials depending on the application. So for filtration, for energy storage, for cultured meat, we're using different ingredients. Right. So our aim is to help to accelerate the growth of many sustainability and health-focused industries such as cultured meat, energy storage, and filtration. We do that by providing up to 100 times cheaper nanofiber manufacturing service for technology companies that use nanofibers in their products or processes. In addition, we are doing vertical integration in tissue engineering and cultured meat where we have our own products launched. Nanofiber market is growing 36% a year. The use of nanofibers in life sciences and biotechnology grows even 74% annually. So that is why we're focusing right now on these high margin, low volume markets, but ultimately we move to energy storage and bio-based filtration. But already we see that the potential to grow in the cultured meat industry is massive. We have already paying customers. We are doing development projects for the really large corporations. where we're developing materials for a fee, and after that we start producing these materials, which is our main business model. So far we have relied mainly on grants, competitions, but we have also received a Techstars convertible notes. Currently we're closing our seed round. We have, like I said, our machinery up and running, MVP launched on the market, and we're selling in decent amounts. We are a team of material scientists, material technologists, and my co-founder Marianne has a background in business development, business consulting, and my background is in material science and materials technology. So that's pretty much it. I'm happy to answer all your questions that you might have, and thanks for inviting us to XTC finals.
Thank you.
What's your, let's say, entry angle with energy storage? Is it to somehow separate the electrolyte, the anode from the electrolyte? What's the, let's say, the entry point, the advantage?
Yeah, in energy storage, the main benefit of nanofibers is in a high surface area to volume ratio, so electrode materials. So in supercapacitors, for example, also applicable in fuel cell industries where really high surface, materials with a high surface area are really beneficial to increase the efficiency. So, for example, if we put nanofibers into supercapacitors that are not being done right now because of high price of nanofibers, we could increase the efficiency of simple supercapacitors at least 8 times, just by replacing the material, electrode material. Yeah.
Thanks.
This is Hannah jumping in. I'm wondering, you showed comparisons to similarly structured nanofibers, but have you done comparisons towards different structures that have been shown to be mass producible at the nanoscale? Like crumpled graphene, similar to those?
This is a good point. We have this is a good point for energy storage. It's definitely needed. Our main focus right now, like I said, is cultured meat tissue engineering and wound care, where the material is in contact with the cells, right? So we usually show the difference between the similar materials in tissue engineering, right? So I agree, in energy storage, more important to show the difference or the similarities between amorphous carbon, for example, or activated carbon. Because our main focus is on cultured meat and tissue engineering, therefore the other nanofibrous products make the most sense, because there are so many other technologies how to produce nanostructured materials, but there is no, the nanofibers have been already proven for tens or even more than 10 years to be really promising materials, but so far the challenge has been how to produce these materials on a large scale, right? So that's why nanofibers as a comparison as well.
Thank you, that's great.
Hi, Martin. So how does your technology change from market to market, or does it just remain the same? Are you offering?
I would say that it changes really little. With each material that we're producing, we develop let's say procedure for that. But all the equipment that we're using, all the processes that we're using are kind of the same. There are just, let's say, around 20 different process parameters that we're changing with each different polymer. But ultimately, in each case, the process is the same. We take the polymer, dissolve it, spin it into nanofibers, and then if we are shipping as a roll, then we roll it, basically packaging it. The innovation relies how we pull the fibers from the solution. So there is the main innovation. The physics behind it is completely different compared to the electrode spinning, where the high voltage electrical field is used. We are using completely different forces that are much more powerful, therefore higher throughput. So
what is the timeline for developing such a process?
For us, actually, we started in 2016 with a different focus, developing leather-like textile. We developed this technology because of our own need. We needed a faster way how to produce nanofibers for textile industry. And then in the middle of 2020, after the crisis, or when the crisis started, we understood that actually our technology could make a huge impact also in filtration, in wound care. So therefore, we expanded basically our activities, and therefore we found a cultured meat where the pain is actually the biggest, and there is no material on the market, and even none being considered. So therefore, So it takes some time, I would say. For us, it took around 4 years to develop and also to scale up. So we have scaled it up around 50 times. It takes some time. But now the technology is developed, ready to scale.
Thank you.
Great. Thank you for your presentation, Marte, from Gelitex.
Thank you as well. Take care. Bye-bye.
Okay. Okay, let's invite BFC, bioenzymatic fuel cells, to set up on stage.
Hi there, can you hear me?
Yes, we can hear you and can see your deck.
Okay, then I start. So hi everyone, my name is Jules Hammond. I'm the CEO and co-founder at BFC. And in one sentence, BFC make electricity with papers and enzymes. Our paper biofuel cells offer an eco-friendly and sustainable energy solution for low-power electronics. There's a huge trend towards wearable devices, but also single-use or single-patient medical products. Great examples are continuous glucose monitoring patches for diabetes, but also digital pregnancy tests. There's a huge problem. These devices are commonly powered by lithium, coin, or button cell batteries, which are notoriously difficult and expensive to recycle, with an estimated 15 billion primary batteries ended up either in landfill or incineration every year. So at BFC, we've taken inspiration from biology, and we're using glucose and oxygen as our fuels. We've developed a paper biofuel cell as a sustainable solution, and because it's paper-based, it's thin, lightweight, and flexible, great for wearables, but also for packaging. We use enzymes, which means we avoid the use of toxic materials found in conventional batteries. In fact, our technology is completely metal-free and plastic-free. We use glucose and oxygen, which are proven to be abundant biofuels. And we can then activate our technology using diverse liquids such as biological samples, environmental fluids, or using our onboard patented blister or liquid reservoir technology. The technology is a stack of carbon and cellulose paper layers. And we have one enzyme which oxidizes glucose, creating electrons, a positive current, and a different enzyme which reduces oxygen into water, creating a negative current. You combine the two reactions and you create a biofuel cell. As a CNRS academic spin-off, we have a strong patent portfolio, and really we're focused on low-power solutions where we combine BFC powering a microcontroller, some MEMS sensors, flash storage, and then a wireless transceiver to communicate over protocols like Bluetooth Low Energy or Sigfox LoRaWAN. And we've partnered with companies like STMicroelectronics to use their system-on-chip solutions, 3M for medical adhesives, Avery Dennison on robust papers, to combine our paper biofuel cell with a digital flexible PCB. And because our devices are paper-based, we can augment the size to adjust for different form factors, but also to deliver different amounts of power depending on the end application. The competition clearly is the status quo, the coin or button cell batteries, and then emerging flexible battery technologies. But in terms of green energy solutions, you have things like flexible PV cells. Now, if we look at all the energy harvesting technologies, for photovoltaics, you have the problem of high power density only in direct sunlight. And for thermal vibration and RF energy harvesting, the power generation is erratic. In comparison, BFC provides power on demand within a few seconds for minutes to months, depending on the application. BFC is currently scaling up our production, industrializing from sheet-to-sheet robotic assembly to roll-to-roll. The key thing here is increasing production capacity to hundreds of thousands of units per day. And by printing our technology, we can move from pricing comparable to lithium to pricing of alkaline cells, so we can really compete and offer our green solution. We see exciting opportunities in wearables, medical, IoT, and logistics, which are markets expected to grow to tens of billions of dollars in the next few years. But more specifically, we are already working with leading companies who are expecting tens to hundreds of millions of units of demand in the next few years. The team is scientists, engineers, and business strategists, but most importantly, problem solvers, a strong academic team and talented interns, an amazing advisory board, C-level, previous deep tech startup experience. The company's raised 5 million of euros of funding to date, awards such as CES Innovation Award, Nature Merck, and I finish on our slogan, which is together power the future of nature, because we cannot do this alone and we have to take this disruptive technology to the public. Thank you.
If I can jump in, this is Hannah. I have a question on your production scaling. Have you identified partners who you're going to work with to reach the scales?
Yes, so we currently work with a company called Actemion who make medical device production lines for companies like Becton Dickinson. We have a throughput of 1,000 units on the sheet-to-sheet assembly per 8-hour shift, but we've already started tooling tests for a roll-to-roll machine with a company called DCS, Dory Converting Systems, who are based in France and America and work with companies like Tesla to produce pouch cells. And we're confident we can achieve 100,000 units per day at slow throughput speeds up to 1 million units per day. And we're already trialing that to have the production line through the factory and site acceptance test by the end of next year.
Thank you.
What's your ideal investor for the next round? Are you looking for someone that can help you scaling up your business? Are you looking for financial investors? What's your thoughts on that?
The first point I would mention is our currently VC investors are French-based. We're looking for either another European fund, but interestingly, maybe a US or Japanese-based investor to help us, to first of all, set up business development opportunities in these countries where we know there's a big market, but secondly, to set up secondary satellite production sites because the clients need the units within a few months and really to ship from Europe to US causes new problems. On the other hand, we're also interested in large corporations that understand regulation, and particularly in the health or medical markets, it can be complicated.
Okay, thanks.
Hi, Jules. What is the plan to, so one question, I actually have two questions, sorry. So you mentioned you have partners with, you're partnered with 3M. Are they a supplier or are you paying them? What does that partnership look like?
It's a strategic partnership. It's a win-win situation. Currently, 3M, we work with them to identify suitable adhesive materials for wearable products because depending on where you attach the patch on the skin, you need slightly different adhesive properties. So it's not an exclusive agreement. It's just strategically, it's a win-win situation where they see a new market opportunity. And of course, we get the high expertise of 3M.
And my next question is, how does this integrate with existing technologies? So it's an entirely new product. How do you convert, for instance, a device that I'm currently using to be able to utilize?
So we can kind of make the form factor similar to traditional coin cells or cylindrical cells, but it almost seems to lose a lot of value proposition. The great thing about our technology, it's thin and flexible. So we are working with huge companies who are interested in millions of units per year. And we currently kind of try to converge to a single design solution. We imagine in the future you could have a new format like a AA, AAA, but for thin, flexible cells. So typically we keep the anode and cathodic contacts the same for all of the different dimensions so that really you can just switch out depending on the capacity that you require.
Thank you.
And this is Hannah again. I have one more question. What is the recyclability or disposal process for one of these as well?
Good point. So one of the customers we're working with are the largest producers of cardboard packaging in Europe. They've already done recycling tests for both the flexible PCB that we've developed with ST and proved that 99.7% can be recovered on a trial size of 1,000. in terms of biodegradability, we've done tests to ISO ratings for sludge, slurry, anaerobic, aerobic, biodegradability. And fundamentally, our technology is paper, carbon, enzymes, glucose. So, actually the tests we've done with CEA and CTP, the Technical Center for Paper, have proven that actually we have a positive impact on the environment. The carbon acts as a fantastic fertilizer. You have the glucose there. So in terms of biodegradability, it's a great thing. Now, we're also working with some strategic partners that do printed organic electronics. So you could imagine in several years, you have the passive electronic components printed on what's called an interposer, and you have a single integrated circuit at die level, which is what we're working with ST to produce. And then the environmental impact for a digital tracker is, negligible. But the benefits you can provide with a digital platform for wearable medical or also high value asset tracking is immense.
Thank you.
Thank you.
Great. Thank you, Jules from BEFC. Thank you for your presentation.
Thank you.
Great. Just a moment for the judges while we invite our last presenter to the stage from EH Group.
So good morning, everybody.
Just a second. Let's give the judges another
Sorry.
No worries, 15 seconds. And judges, give me a thumbs up if you're good to go.
Hannah's good.
Good.
Okay, great, Chris, you have the floor.
Very good. Once again, morning. Thanks for the opportunity to be here. Chris Brandon, co-founder of VH Group, based in beautiful Switzerland. So as hydrogen accelerates as the energy vector to decarbonize the energy transition, two major challenges remain with fuel cells for more widespread adoption of that technology, that of cost and complexity. And these are the two things we've set out to solve. So we have redesigned our fuel cell stacks to the microstructure level, which basically means they end up being much more compact and lightweight. We have about 1.5 to 2 times the power density of that of our nearest competitors. We're also able to simplify the architecture around them, which means lower balance of plants, higher efficiencies, and lower cost there. And because our fuel cell stacks have such a low cell pitch, they're ideally suited for mobile applications in particular. But this is also designed for manufacturing, where at the moment the assembly process is extremely arduous, requires numerous partners, very expensive. We're talking about 800 to 1,000 euros per kilowatt at the stack level alone. We're working with a Swiss industrial partner since 2018 on a straight-through process based on the cell structure that we have, which enables us to basically print a stack in a matter of minutes rather than half an hour. And that is the key to driving down the cost to below 100 euros per kilowatt at scale. We've filed 5 patents so far, which go from the stack design, some of the core components of it, and we're in the process of filing further 4 or 5 more, actually all the way through to the industrialization process. We've also been fortunate to work with the European Space Agency for the last couple of years, testing our stacks on thermal tests, vibration tests, and the rest. We've reached our TRL 6.7. Our stacks and systems have been out in the deployment from various stationary and mobile applications, from electric commercial vehicles, forklifts, and aerospace companies, and the like. On the stationary side, we're just going to be deploying our largest stack, which goes up to 250 kilowatts, which is nearly twice the size of the next largest in the market. For actually, in this case, a stationary application, an off-grid EV supercharger, but this stack in particular is very much the building block for those harder to decarbonize areas of maritime, heavy goods, diesel train replacements, and the rest. Because these are the markets, certainly within mobility, which is where fuel cells come into their own. So anything that requires payload, extensive use, range, buses, heavy good vehicles, maritime, even aerospace, and all the way back down to forklifts where they're already established. Competitors are industrializing rapidly, but very much sort of following the standard approach and technology, which we think will hinder their efforts in trying to get the cost down and actually get the performance numbers which we're able to. We operate either as a stack or system supplier, but more interestingly, we've got quite a few interesting developments with some OEMs and tier one manufacturers where we do a co-development on the system side, which is then optimized for our stack. And it's somewhat the Gillette model. Our stacks are replaceable, but it's kind of difficult to do so. And the key is then to get the cost down, which is where our production process comes into its own. We have a team of 12, of which the core have a background in fuel cell systems, but also very much in the control and automation of things. We're based in these beautiful labs here. The sky isn't looking quite so blue today, with space to expand for our production next year. We've had some good support from the European Union, as well as Solar Impulse Foundation, which we work with closely. We're doing a Series A early next year, about 8 million Swiss francs, having raised about 8 million Swiss francs already from seed, grants, and a pre-Series A, which we've actually just finalized right now. So we're looking for partners that share our vision for the scope that fuel cells can provide. We see this as a long-term opportunity. Thank you very much.
Thank you, Chris.
Chris, I apologize if you mentioned it already. What's your main, let's say, strongest competitive advantage against companies like Bloom, Plug Power, Ballard, Bosch, these large fuel cells manufacturers? Are you targeting a niche, or what's your view on that?
Yeah. So each one of those falls into slightly different segments. But there's three key things that we're better at. So for starters, our stacks are literally half the size of that of PowerCell, which is licensed to Bosch, Bloom, same thing, etc. Just to give you what one of these things looks like. This is a 35 kilowatt stack that'll power quite a lot. This will be enough to power your apartment at home at 5 kilowatts. So size. Because we're actually not doing a sort of traditional approach on stack technology, this is quite a sort of left field thing, we're able to simplify the system architecture. So we operate at much lower pressures, which means that we basically get about 5 or 6% of increased efficiency at the system level, and therefore have a much lower compressor, fewer parasitic loads. But the key is then in the production process. Even with Bosch and the rest of them, it literally, the state of the art now is half an hour to produce a stack. We're producing a stack in about 4 to 5 minutes with all the quality controls done along the way. And it's a combination of all those three where we feel we have an edge.
Okay. Thanks.
Sure.
Hi, Chris. Who are your current clients right now, or customers?
So it's pretty broad range of them, but the most interesting ones are sort of large energy groups. So they're using these for much larger sort of containerized, 1.5 megawatts for either data center backups, long-term energy storage. And in the mobility space, it's sort of equipment manufacturers such as large forklift players, where this is already an established commercial sort of viable versus lithium-ion battery, looking to test and deploy them across their whole fleet.
Okay, and you've been operating since when?
Oh yeah, I forgot to say that. Since 2017.
Oh, since 2017, okay.
Yeah. I mean, I gotta say, what a difference 18 months makes, because honestly, 18 months ago, there was not much talk of fuel cells and hydrogen, so maybe COVID hasn't been too bad in that respect.
Right. Yeah, I don't have any other questions.
What sort of partner would you look in the future? If you're looking for an investor or partner, what's your ideal investors?
So a few things. I mean, we're looking for partnerships across a variety of spectrums. So basically, even just deployment partners, we're looking for in discussions with also assembly partners. So as much as we build the stack, if there are sort of tier one automotive groups and other engineering groups who are good at assembling things, that helps. And on investors, just the key for us, we haven't got any VC investments yet. We've done it. I basically have a hedge fund background, which I ran for 20 years. Is having the right time horizon. That's probably the most important thing for us. Is that there's a momentum and there's a buzz about hydrogen and all the rest of it, but this is going to take time to play out. And I think this is more a 5 to 10 year play than less. Opportunities may come less sooner, but I think we have to think a little bit longer term.
Okay.
Actually, Chris, speaking on that timeline, what would you say are some of the biggest pain points that you're facing right now?
Okay, in the very short term, we're struggling to find enough engineers. Certainly anyone with fuel cell background is like a red hot property right now, so that's tough. I think the next big pain point for us is going to be when we're taking delivery of the production machinery, like all 5 modules in stages, but towards the end of the year, going from we're now semi-automated production to full automated. There's a lot of testing, debugging, infrastructure building, scaling up the team. That's going to be a challenge. And then, it's engineering. It takes time. It's real things, and there's also a little bit of an educational process going. Maritime is a big sector that's interested, but it doesn't just plug in to replace the diesel engine. You got to think things through. What sort of size of hydrogen storage? There's other bits of the ecosystem you have to work with as well.
Right. Okay. Thank you.
Yeah, sure.
And Chris, I have one question. This is Hannah.
Sure.
How do you envision your growth and standing out amongst the competitors? Because there is a huge educational piece of it, and not every customer might be aware of you versus someone who has a stronger name.
No, that's true. Albeit it's a pretty, still a pretty niche market. Like, the names you mentioned, there's not that many more than that. So, there's maybe a dozen incumbents, and, we're now sort of coming out of, stealth. And the players who start shopping around for fuel cells, you tend to kind of cross the same sort of people at, Hydrogen Europe and yada yada. So yes, I'm not underestimating that we have, there's some work to be done there, but we don't have to stand out amongst 1,000. And the more we deliver on strong stack technology, will I think speak for itself.
Thank you.
Thank you. Any more questions from the judges?
Yeah, if you have a couple of minutes, I was very curious to hear about your use case with the, let's say, power backup applications for the, let's say, data centers in general.
Mm-hmm.
What sort of reliability are they looking for? What is it already a big part of your revenues?
So no, it's not. We've done smaller ones. So 250 kilowatt, containerized backup, which is the first one. The one that's on the drawing board now is 1.5 megawatt containerized system. So it combines. It's got batteries and hydrogen storage within it, but then there's the large hydrogen storage is outside. You have to have a battery because the fuel cell system takes, 20, 30 seconds to go to full power. If you have a small battery, and that's fine. So it's the beauty of that is it's already like a 1 megawatt, 1.5 megawatt diesel generator is highly expensive. You're talking like $500 a kilowatt kind of thing. So you're not that far off already to begin with. You have very low maintenance. Literally once a year you check the air filters because there's no moving parts. And it's required to at most last 3 days. So it's more about this sizing your hydrogen storage which is the challenge in this scenario.
Okay.
But the really interesting thing is to actually use those not as a passive asset, but to combine it with an electrolyzer and the storage, and to use it much more dynamically. And because of the volatility in electricity prices, you can actually pay off your capex in literally a year.
Okay.
Sorry, that was technical.
Thanks.
Great. Thank you for your questions, judges, and thank you, EH Group, Chris, for your presentation.
Yeah, thank you all. Thanks for the opportunity. Very fun.
Thank you.
Thank you.
And I just want to say, we've heard some really compelling solutions over the last 2 days addressing sustainability and energy issues. So our hearty congratulations to the entire 17 companies from this year's Cleantech Energy and Environmental Solutions finalist cohort. We're really inspired and also impressed by the great work you're doing to create a radically better world. And also I want to say a big thanks to our judging panel, Hannah Bailey, Giancarlo Savini, and Leonie Weirkuhn for your great thoughtful questions. But now you have the hard job of selecting one winner from this really incredible cohort. So all the finalists now are part of the XTC family, and we'll continue to support you throughout your journey by making meaningful introductions that could help you grow. So to the entire class, it is an amazing achievement that you have all risen above a super competitive pool this year with applicants from almost 100 countries, and you're all winners in your own right. And these exceptional companies are looking to connect with investors and corporate partners. So if anybody watching is interested, please reach out to me or directly to these founders. And to learn more about the companies presented today and all the startups from XTC 2021 Global Finalist Cohort, please head to go.philo.com/XTC and visit their virtual booth. And you can still vote for your favorite startup from this year's class, because the winner of this People's Choice Award, along with the category winners and special award winners, will get to pitch at the finale event, which is our global finals presented by TechCrunch on July 22nd, to battle out for the crown of overall winner of XTC 2021. So there's still time to vote. The deadline to vote is July 11th. So that's one way to send your favorite startup and get them on that TechCrunch stage. And now this wraps up the entire XTC 2021 category final series. We will be publicly announcing the category winners tomorrow via a press release. So keep your eye out and head to our website for more details. And also just head to the XTC our YouTube channel to catch up on video recordings of all the category final sessions. And while you're there, also check out our most recent coaching videos featuring some really great speakers. And then lastly, you're all invited to attend this grand finale, the Extreme Tech Challenge 2021 Global Finals, hosted by TechCrunch on July 22nd at 9 a.m. Pacific time. It is open and free for the public to attend this virtual event. So join and watch all these top contenders pitch, but as well as stay for the virtual network with thousands of VCs and big company executives, tech founders, and policymakers for this event. So follow us on social media to get the latest news and updates from the XTC team. And I want to just thank everybody for joining today, those who are staying up late or waking up early. It's been terrific having you here, and I want to wish you a great rest of your day. Thank you.